Hi everyone, this is just a short video going through the template that you'll find in Teams. This is the Year 8 one obviously. So you'll see here you need to fill out the information at the top and follow the guidance given in every subtitle. Before submitting, make sure you remove the guidance given to you by your teachers so that all you're submitting is your work. You're very welcome and I advise you to keep the subtitles. But everything else goes, and save it as your name and then the title of the report, not just Year 8 PRAC report. Notice that the word PRAC has been taken out here, title of investigation, much more professional and scientific, or experiment if you prefer. The introduction will be new to most of you, and what this does is it sets the context for the experiment. It explains some of the key terms and some of the ideas that are being investigated. So if you're measuring a particular chemical reaction, you need to describe the chemicals involved and the conditions that you're testing it under. If you're measuring, the example here is the boiling point of water, you need to explain what happens, what does boiling mean, what is water, what is your independent variable and how is that changing? Is there any existing knowledge about what you're investigating that you could include in your introduction? You might relate it to particle theory or collision theory a bit later on. So try and do a little bit of research into the experiment that you're doing so that you can actually build an informative introduction. It wouldn't be unusual to include a reference in there, although it's not essential in Year 8. The aim obviously explains what your objective or purpose was. So this doesn't have to be particularly conventional. The hypothesis has a very clear structure that we can't break from. The aim can be plain English. It is a really good idea, though, to stay past tense and impersonal in your report. So what that means, we'll talk about that when we get to the method, actually. So the aim is just a general purpose. What you started out trying to investigate. What was your question? Then you get to the hypothesis, which is a prediction, a statement of belief, but it also has reference to what you're changing, how you're going to measure any effect, so the dependent variable, and a clear prediction about what you expect to find. That does not have to be correct. Okay, so if your prediction turns out to be incorrect and the data doesn't support that, that's totally fine. The hypothesis just gives you a starting point, and sometimes it's actually easier if your data doesn't support the hypothesis. It gives you lots to talk about. The convention is usually, if this changes, then this is expected to happen. That's a pretty classic way to construct a hypothesis. Otherwise, it's hypothesized that is a good start because it is impersonal and it was hypothesized. That maintains past tense. Students with good grades, as it says here, will get into a good college or university. Here what you're doing is you're making a clear prediction, so you're not saying grades will affect university selections, you're saying in which direction. So good grade will mean a better university, and a poor grade might not, might go in the other direction. So if you can see what I mean by a prediction, and a direction with that, you're showing exactly which way you think the data is going to point. And in this one, the grades will be the things that are changing, and the college is almost the outcome, so what's being measured. If you drink coffee before going to bed, then it will take longer to fall asleep. So the drinking of the coffee is what's being changed. So you might have a group that have drunk coffee and a group that haven't. And the time it takes to fall asleep is the dependent variable. Now, it might be useful for you while you're learning how to construct a practical report to actually list anywhere in your report, really, towards the beginning, the independent variable with units and all the range of that variable that you're testing. The dependent variable, so what you're actually measuring with units, and also controlled variables. List as many controlled variables, so as many things that you didn't change as possible, so that you are ensuring that the method or your report reflects the fact that you're trying to achieve a fair test. You're trying to control everything except for the independent variable. That's the only thing you are changing. Apparatus lists often can be just taken straight from the method that we've given you, or your text is in your textbook. Be mindful that you didn't necessarily use everything in exactly the same way, and a diagram can really be very useful. Just taking you back to the purpose of this report, obviously you're describing your ideas and your experimental process and your findings, but you're also trying to make it as detailed as possible so that somebody else can follow your method exactly and achieve the same outcomes. So if someone picks up your report, they can copy exactly what you've done and achieve the same thing. Okay, so if you include an apparatus diagram, that shows the reader how to organize the equipment. Make sure that in science, any image, any diagram, any graph, any table has a figure number and a title. Very important. Ideally, diagrams are labeled as well, and they're supporting the method or the discussion perhaps. I will just go through the method in this section, and then I'll make another video for you on the discussion and conclusion. So when you are constructing a scientific method, please refer to this document, but make sure that you state in past tense, so what was done, not a list of instructions. So that means that you do not write light the Bunsen burner or connect the tubing to the gas outlet, because that's an instruction. You're telling somebody what to do. Neither do you write I lit the Bunsen burner. Yes, past tense, but the word I makes it personal. So you need to maintain impersonal language. The Bunsen burner was used to heat the water. Always past tense. If you're struggling with that, then speak to your teacher. It can be one of the hardest things to crack. Describe exactly what you've done so that, as I said, somebody else can copy exactly. Anything else in here? Let's just have a very quick look at the results. Results can be a written paragraph about the findings, usually also has a table, and that table needs a title and it needs units in the columns and the rows, not necessarily in the body of the table, and then a graph of your choice, but the correct graph that represents the trend or the findings as best you can. So that means that you need to review when to use a line graph, when to use a bar chart, when to use a pie chart, and make sure you use the right one for the right sets of data. We can go through that as well. We won't talk about the discussion at this point. That will be in the next video. So please download the template. Make sure that you remove all of this advice once you have written the sections yourself and before submitting. Well done.